Okay, as continuation, maliban doon sa 16 kilonewton per meter na load ng ating beam, it's so happen na uniformly distributed. Meron pang isang load na kailangan nating i-considera. Yun mismo yung bigat ng mismong beam. Kasi nga ginamitan natin ng steel beam, no? W shape. So happen na yung weight ng beam itself, kailangan talaga i-consider yon. Hindi pwedeng i-neglect yon. Kasama yon sa load na ating i-consider sa pag-design ng structure. Sa pag-check din kung safe ba ito o hindi. Safe ba ang flexural stress na ating nahanap, na actual flexural stress? Kailangan na i-consider yung weight of the beam. So, magbabago siyempre ang mga reactions natin. Originally, kanina, nung kinupit natin ang R1, hindi ganyan yan, tsaka yung R2 eh. Pero nadagdagan kasi ng 0.803 na kanina nasa kilogram per meter yan, kinonsider natin as, kinonvert natin lang kilonewton per meter. So, kasama yan, class. Do not forget that. Kasama yan sa pagkakalculate. Di ba kanina pinakita ko yung superimposed loads, yung maximum weight of the beam, ang maximum moment, at saka yung shear due to the weight of the beam. Sa design procedure, pag nasa steel design na kayo, o reinforced concrete design, or timber design, na pang-year na, sigurado anak, sigurado mga anak, gagamitin yung lahat ng mga nabanggit ko ngayon. Binibigyan ko lang kayo ng idea about your future subjects. Check yan. And then, magbibilang kayo ng mga table dyan. Mag-iipon kayo ng mga table. Well, hindi naman kailangan kabisaduhin yung table sa mismong licensure examination, ibinibigay sa problem ang table. Hindi yan pinapamaster, no? Kasi sobrang dami ng mga data dyan eh. Na kailangan i-memorize yan. Ang kailangan nyo lang matutunan is kung paano gamitin yung table. Now, we can now calculate for our maximum moment. And here is it. Saan ang galing yan? Siyempre, yung area nung shear. Okay, balikan ko, no? Para maintindihan ninyo. Diba, ito, in-add natin sa 16 kilonewton per meter kanina, no? Yung R1 natin, na bago din. Ito yung R1 and R2 natin, 84.015. Natural, tiyak ganito mangyayari dyan. Diyan. Magiging 84 yon, point something. Ito, ganun din. So, compute mo yung area, 1 up, 5 times 84, yun ang maximum moment, hindi na 200. Mababago na, makakaroon ng revision. It is because of the added extra weight and that is the weight of the beam. Naintindihan ba ninyo? Naintindihan ba ninyo, class? Yung example na yan na ibinigay sa licensure examination before, lumitaw sa exam yan. Baka pwede rin, na-take up ko pala yan nung ako yung nag-take ng licensure examination. Ayan, tagal na nun, di ko na maalala. Okay. So, pwede na natin i-calculate ngayon ang ating flexural stress. Okay? Maximum moment over section modulus. So, anong section modulus ang gagamitin natin? Yun yung data na naanap natin doon sa W-shape na beam na pinili natin na W 610 by 82 yata yon, at ito yung SX value niya na nasa table. Okay? So, ang ating flexural stress na mahanap is 112.3 times 10 to the 6 Newton per square meter, or we can change it into megapascal. 112.3 megapascal. And that's it. Ito yung ating final answer in that given problem. See licensure examination board exam problem number 3. So malinaw ba ang problem number 3, class? Klaro ba ang pagkakapaliwanag from problem number 1, problem number 2 hanggang problem number 3?
Yes po.
Okay, so let's continue. And then we have the fourth problem, another CE licensure examination. A concentrated load of 90 kilonewton is applied at the center of simply supported beam 8 meters long. Kung nasa gitna yan, 4 meters. 4 meters. Nasa sentro. Yung 90 kilonewton natin, no? And it so happen na ang requirement dito, select the lightest suitable W-shaped section using allowable stress of 120. Again, gagamit na naman pala tayo ng W-shape ng beam. So still design tayo dyan. Still ang ating gagamitin na structural member para sa ating beam. Hindi siya reinforced concrete. Now, ganyan ang figure natin kung susuriin natin no, sa pagkaka-state ng problem. Definitely yan ang ating beam na may reactions na tigpo 45. Symmetrical naman yan. Pag nahanap mo ang isang reaction, para mo na rin nahanap ang R sub 2 dahil nga nakasentro naman ng 90 kilonewton at symmetrical ang ating beam. Unless hindi yan symmetrical, magiging unsymmetrical, so magkaiba ang R1 at R2. But in this case, pareho silang tigpo 45 kasi pag-aatian nila yung 90 kilonewton. So yung mga binigay, yung P-load natin na 90 kilonewton, actually ito yung ating P value. Usually kapag concentrated load ang ating given, P ang ating ginagamit na symbol. And then, ang isang given na ibinigay is the allowable flexural stress, 120 meganewton per square meter. Now, what do we do then? For our solution, again, let us draw the shear and moment diagram since you already know how to do this. Therefore, computing the area of this rectangle, we can have this maximum moment of 180 kilonewton meter. Kasi nga, 45 times 4. Area computation, yun ang moment natin. Okay, alam naman niyo kung paano na i-drawing yan. Napakasimple lang ng given natin. Again, let us use the flexural stress formula M over S. Again, involved na naman ng section modulus. Okay? So let's proceed. Given ang allowable stress, no? S is equals to M over flexural stress. The moment is 180 kilonewton per meter. Kilonewton meter, not per meter. 180 kilonewton meter. And then the flexural stress allowable is also given. So I think we can now calculate for section modulus. Kasi given naman ang M at saka yung denominator natin na flexural stress allowable. Computing for the S, we have 1.5 times 10 to the negative 3 and then i-convert natin sa cubic millimeter. So we can have 1,500 times 10 to the 3. And again, since we already have our S, we have to select now again from the table. And so happened that in this case, assuming we have the table, napili natin sa pagpili gamit ang table is W530 by 74. Yan. At kung ang napili natin is W530 by 74, gamit ang table, assuming nakita na natin sa table, nahanap na natin, ang value ng ating S is that 1. And the theoretical mass or weight is 74.7 kilogram per meter. Yan ang value. So we have to consider again the weight of the beam. Hindi lang yung concentrated load, no? Kailangan i-consider natin ang weight ng beam. Now in this portion, since we have considered the weight of the beam, regarding with the calculation of the moment and the shear, sa pagkakalculate ng additional or extra load, we have to consider the beam as uniformly distributed. Kasi for every meter, affected yan. Hindi lang yung sa concentrated load. Iba ang W, iba ang P. Yan. Kaya nga ito, nag-drawing ako uli ng beam. Kung titingnan nyo sa baba, uniformly distributed para doon sa extra weight. The weight itself ng beam. Uniformly distributed yan. Hindi lang doon, no? Hindi yung dito. Baka mamaya din nyo sa concentrated load, mali yun. Can you follow? Nakakasunod ba kayo? Huwag niyong i-add-on. Extra weight yan. Yan yung mismong weight or bigat ng mismong beam na ginamit natin. Na size ng beam or dimension ng beam na ginamit natin. Ito yung bigat ng section na napili natin na W530 by 74. Okay? So, since symmetrical yan, pareho lang ang computation ng R1 and R2. Magiging pareho lang na 47.928 kilonewton ang ating calculation. Okay, kumbaga dito, inassume na nakaya na ninyong i-calculate yan since tapos na kayo ng shear and moment diagram. Okay? Magdadagdag lang naman tayo eh. Okay. Definitely, yan ang ating maximum moment if we're going to calculate it. And I'm expecting na alam na ninyong maganap ng maximum moment. And that is it. If we're going to calculate it, is given naman yung W, yung 74.7 kg per meter, at na-convert na sa kilonewton per meter, direct substitution na tayo. 4 meter, yung pinaka-gitna, no? 4 meter ang ginamit dahil doon yung position ng ating maximum moment. And here is it. 185.856 kilonewton meter ang ating value. And so, dahil nandiyan na ang maximum moment at may section modulus na tayo, pwede na natin i-compute ang M over S na value ng ating flexural stress actual. Yan. 119.9 megapascal. And it is actually safe. Why is it safe? Safe ba? What do you think? Bakit kinonsider na safe? Class? Any idea? Bakit siya safe? Bakit hindi siya fail? That's my question. Hello? What a very simple question that I gave you. Why I conclude that the value for actual stress in chosen beam is safe. We got 119.9 megapascal. And why is it safe now? Kasi if it is not safe, kung ako yung designer, magre-redesign ako, babaguhin ko yung section. Papalitan ko yung W530 by 74. Mag-aanap ako ng bagong section. Okay? Now, why is it safe? Okay, I'm asking you, class. Aileen, bakit siya safe? Aileen Kabigting? What do you think is the reason? Why is it safe with this actual stress na 119.9 megapascal? Going back to our previous talk kanina sa discussions natin sa ating introduction, ano ba yung mga na-state ko sa inyo? Okay? Okay, let me ask another one. Duay. Sige, ikaw na lang, Duay. Bakit siya safe? Bakit hindi ko nilagay fail? Safe ba talaga siya? Ano yung reason? Walang nagre-reply. Sayang yung oras, anak. We do not have the whole day. Anyone? Bakit safe ang aking conclusion sa 119.9 megapascal?
Sir, it means po mas mataas po yung kaya niyang buhatin dyan.
Pakiulit, Jalen? Pakiulit. Paano pagkakasabi?
Mas mataas po yung kaya niyang buhatin sa 119.9 po.
Yun yung may reason mo. Mas mataas yung kayang buhatin. Papalapit na? Malapit na? Papalapit na? Ito yung sagot natin, ano? Okay, let me go back to the problem so that you can see. Okay, ano ba yung allowable? What do you see with our allowable? Jalene, ilan ba yung allowable natin sa problem?
120 po.
120. Allowable yan. Ibig sabihin, hindi tayo dapat mag-exceed dyan. Okay. So, proceed. E so happen, sa last part, alin
Po,
ba ang
sir.
mataas? Ang allowable o ang actual?
Mas mataas po yung allowable, sir.
Okay.
0.1.
So, ibig sabihin, safe tayo. Dahil kapag nag-exceed tayo doon sa allowable, magkakaroon ng failure sa structure. Magko-collapse ang beam. Magde-deflect yan or masisira yan. Magkakarak yan kung konkreto yan. Can you follow? Magkakaroon ng failure. So dito safe tayo. Okay? Kasi less than. Hindi tayo dapat dumampas doon sa allowable lang. Okay? So ibig sabihin, safe talaga ang paggamit ng section na W530 by 74 na may modulus section na 1550 times 10 to the 3 cubic millimeter. Okay? So safe ang ating structure sa section na W530 by 74 na ating napili. So ang ating mga sagot, yung section na yan at saka itong actual stress ng ating napiling beam. And that's all for our problem number 4. Number 4 na yan. No? Okay, another problem. Now, floor framing. Okay, floor framing tayo. Kailan ba nagkakaroon ng floor framing, no? Okay, paliwanag ko lang. Okay. Assuming, magdodrawing ako, no? Hindi pa ako magsusol. Ano ba yung importance ng floor framing? Okay? Kung reinforced concrete yan, mas mahaba to, no? Ito kunwari yung length natin, ito yung width. And assuming yan, meron pa dito, yan. Continue ko lang, no? Yan, 3 yan kasi. Tapos ano pa, mouse. Okay, length din yan within ito. Now, sa pagko-consider ng loading, o let's say for example, gawin kong triangular ito. Burahin ko yung ibang portion, ano, para mas makita ninyo. Yung tributary area ang binabanggit ko dyan, ano. Okay. Tributary area. Ano bang ibig sabihin ng tributary area? Paliwanag ko lang, no. Gagawin niyo yan. Ina-advance ko lang kayo. O kunwari, square yan, no. Sabihin natin yung distance na to is distance M and that is also M. Okay. If we are about to design this beam, yan. Kita niyo to, no? So yung bigat na dadalhin yan, itong mga naka-shade. Ang kakargayin niyan, yung mga naka-shade. Ko-compute natin yan. Yung mga naka-shade dito, ang magkakarga, ang beam na yan. Okay? Kung ito naman ang ating ko-consider, ang kakargayin niya, ito lang. Can you follow? Tributary area ang tawag dyan. Okay? So sa floor framing, nangyayari yan. Kapag nag-design ka ng beam, maalamin mo yung portion ng ibang structural member na kakargain ng beam. Siyempre, kakargain ng beam ang slab. Ang magdadala naman sa beam ay ang poste, ang column. Okay? So, iwanan na natin yan. So, floor framing tayo. Now, let me read the problem. Floor joist 50 millimeter wide by 200 millimeter high simply supported on a 4-meter span. Carry a floor loaded at 5 kilonewton per square meter. Compute the center line spacing between joists to develop a bending stress of 8 megapascal. What shape load could be carried on a center line spacing of 0.40 meter? Ba't nagkaroon ng floor joist? Alam ko, joist, naririnig ko yan sa timber. Okay? Saka sa steel. Floor joist. Halimbawa, yung mga floor joist, ito yung, okay, paliwanag ko, no? Kung made of timber yan, ito yung beam natin. Ito yung mga beam natin. Okay, girder yan. O, ipapatong yung kahoy dyan. Yan yung beam. Ano ba yung floor joist? Ito yung mga floor joist natin. Yung pagpapakuan ng tabla o ng plywood. Kasi ipapatong yung flooring natin. Mga floor joist yan. Iba ang kalakaran sa timber design kaysa sa concrete. Okay? Kaya lang sa panahon ngayon, wala nang masyadong kinoconsider na sa construction na timber. Maybe sa other country or kaya yung mga two-story na apartment. Dati may timber na apartment ha. Ngayon, ewan ko lang kung meron pa, wala na yata. Obsolete na yung ganong design ng structure. Okay, pakibasa nga. Jeline, ikaw na magbasa. Jeline, anak.
Yung ano po sir, CE board problem
Yes,
po.
pakibasa, anak.
Floor joist 50 mm wide by 200 mm high, simply supported on a 4-meter span, carry a floor loaded at 5 kilonewton per square meter. Compute the center line spacing between the joists to develop the bending stress of 8 megapascal. What safe load could be carried on a center line spacing of 0.40 meter?
Okay. So, yung center line spacing must be 0.40 meter. So, yung spacing natin, no? Para sa mga joists. And then, flexural stress natin, 8 megapascal. Para makabuo tayo, makadevelop tayo ng bending stress na 8 megapascal. Okay, so how do we solve the problem? And receipt. Yan. So, we have a 4-meter span ng beam natin. And take note, consideration of uniformly distributed. And W value is 5 kilonewton per square meter. If we're going to calculate the reactions, since it is symmetrical, we can have 10 kilonewton per meter. But, paano ba nangyari yon? Diba, ito yung R natin, no? So, this is 5 times 4. And 20 ang product niyan. 20 divided by 2 is 10. Dahil symmetrical yan, definitely mag-aati yung dalawang reactions. Now, ito yung ating S. Okay? Now, let us calculate now yung pinapahanap na safe load could be carried on a center line spacing of 0.40 meter. How do we do that? For S, meter floor with R1 is equals to R2 must be 10 times S. So, i-multiply lang natin ng S, yung ating 10 kilonewton per meter na reaction. Then, we have to compute for the section modulus. Section modulus, kapag rectangular, is BH square over 6. And then, we have it as S equals to 3.33 times 10 to the negative 4 cubic meter. Yan ang value ng ating section modulus. And then, after nahanap yung S, for the maximum moment, considering the section AA, makakat tayo. Considering left of AA, alam na ninyo yan dahil marunong na kayo na shear and moment diagram. Okay, we can now calculate for M and we can have it as in this equation. Okay, that is our equation for maximum moment. Computing M is maximum at X equals to 2. Siyempre, sa gitna yan. 4 meter lang ang span, so siyempre ang maximum moment sa 2 meters sigurado yan. Dahil symmetrical naman ang building. Symmetrical naman ang beam ng ating structure. For the maximum moment is 10 kilonewton meter. Now, continuation, flexural stress equals to M over S. May M na tayo. May S tayo kanina. Okay? Direct substitution. We have now our moment as 2,664 Newton meter. So yan ang ating moment. And equating it, this moment to 10,000 S Newton meter. Kinonvert ko sa Newton, no? Kanina, 10 S kilonewton meter. Yan, ngayon, kinonvert ko sa Newton. Bakit? Kasi nasa Newton yung moment natin eh. If with this S, 0.4 meter, so this is the value. Ang R1, R2 natin are actually equal to 0.8 W kilonewton. So again, direct substitution with our moment equation that we have constructed a while ago. At midspan, M is maximum. Definitely, dahil symmetrical yan. Uniformly distributed yung ating given kanina at saka may, ito siya, no? Uniformly distributed siya. Definitely, a maximum moment at the center of the beam. And here is it now. Pwede na natin i-calculate ang ating W. 3.33 kilonewton per square meter. As simple as that. And lumitaw yan sa licensure examination. Alam niyo nung kami yung nag-exam during our time, 30 lang yung problem sa design. Pero sasagutin namin yon within 4 hours. 30 items. 30 items sa math, 30 items sa hydraulics, 30 items sa design. Tatlong category. Pero ngayon iba na. I think 75 items or 50 items. Ilan ba sa balita ninyo, Duway, ngayon? Tigilang item na lang. Yung ibang mga batch, naging 100 item per category eh. Pero mas dumali per item. Unlike us, noong 30 lang, puro yung mga problem na ibinigay sa amin. May hirap talaga. Grabe yung hirap. Kasi konti lang. For as long as dumarami yung item na ibinibigay, ibig sabihin, mas na-enlighten yung difficulty per item. Balita ko, ilang ngayon? Sa balita nyo, Duway, ilang item per category? Yan ba si Duway?
Unstable daw po yung internet, sir.
Okay. Jeline, may balita ka ba kung tigilang item ngayon?
Wala po, sir. Di ba po iba-iba yung ginagawa?
Okay. I think siguro 50 or around 75 items at present. Alam ko kasi binawasan sa 100 na naman ulit eh. And that is our example number 5. Now we have example number 6. Unsymmetrical beam naman tayo. The inverted T-section of a 4-meter simply supported beam as the property shown below. The beam carries a uniformly distributed load W over its entire length. Determine W if yan ang ating mga stresses. Less than or equal to 30 megapascal or para sa ating another stress, C, 70 megapascal. Okay. So ito yung ating inertia value. And then ito yung dimension ng ating T-beam. Meron din tayong mga T-beam, kaya meron kayong topic sa design. Design of T-beams. Merong ganun. No? Solution. Since uniformly distributed yan, again, cutting section lagi tayo, AA. 4 meter lang yung span. Pinapahanap yung W, unknown siya, pero binigay yung mga given natin. So this is the calculation. Neglecting the weight of the beam. We can calculate for R1 and R2 as 2W. Bakit? Kasi ang R natin dito is 4W. So W times 4. So dalawang W yung mga reactions natin dito. Tsaka sa right, since symmetrical. Since sabi dito unsymmetrical, let us see later. Asymmetrical eh. Bakit siya naging asymmetrical? Let us find out. Left of AA. Nag-solve tayo ng moment. At midspan, yan ang solusyon. Ipa-plus ko na lang sa inyo. Tension. So, tensile stress tayo, no? So, ang moment natin, in terms of tension, we can have it as 2W is equal to 7,500. Ano ba yung binigay na given kanina? Tingnan natin. 20 ito, no? Okay, yung mga given natin. Per meter, T natin is 30. And then yung I natin is 20. Ito yung sa neutral axis natin. Then 160 and then 80 yung mga dimensions. And it is it now. The value that we have. For the compression, yan ang calculation natin. The shape load that we're going to use is actually the lesser one. Yung 3750 lang. Okay? Mas shape siya dyan. Pipili tayo from tension and compression and we're going to use the shape load of 3,750 Newton per meter. Symmetrical naman yung beam, ah. Okay. I don't see yung T-beam. Okay. T-beam. T-beam ang ginamit natin. Hindi symmetrical yung ating dimension, no? Kasi ganyan siya. Pero yung mismong beam, yung pagka-uniformly distributed niya, symmetrical. Yung shape lang ng beam ang hindi symmetrical. Okay. Next problem. Horizontal shearing stress. A simply supported beam per meter long as the cross-section shown. Determine the maximum uniformly distributed loads can be applied over the entire length of the beam if the shearing stress is limited to 1.2 megapascal. And this is the given beam. Again, we have computed for the reactions. We have 2W Newton both reactions. And yan ang ating dimension ng beam. 100 by 150 and then 150 by 200. Okay, allow siguro yan. Walang laman yung dito, no? Okay, kasi dalawa yung dimension niya. Left of AA, we have B is equals to 2W minus WX and then B max is equals to 2W. Computing for our inertia, neutral axis, BH cube over 12. Okay, halo nga siya kasi yung inertia ng ating bigger dimension na 150 by 200 is this one. Ito. Ileles natin. Yun. So kasi ito lang yung kino-consider natin yung naka-shade. Yan. In order to compute for the I, yung sinade ko lang, no? Okay, let's proceed. So shearing stress now, di ba, napag-aralan na natin yung shear stress sa simula. So parang review na lang yan. And alam nyo naman kung paano na mag-compute ng inertia. Okay, so we can have now the value of our shear. And equating it into 2W, we can have now W as 4,600 Newton per meter. Have a review of our previous lessons about shearing stress. Balikan ninyo yung mga napag-aralan natin dati. And for your exercises na gagawin, maliban doon sa mga problems, wala pa pala akong binigay sa inyo na assignment dito sa mechanics. Ito pa lang ba? Wala pa akong binibigay na assignment sa inyo, class, maliban dito?
Yung moving load, sir.
Okay, maliban doon, ipapasa nyo rin ng mga nandito.
Yung moving loads po.
Kailan ba yung deadline na ibinigay ko sa moving loads? Wala ba akong binigay na deadline?
Nung 12 din po, sir. April
Yung araw
12.
din.
Naipasa
Yung
na.
araw
Naipasa na, no?
April 12,
Yes
sir.
po.
Okay, naipasa na. Nagpasa na ba kay lahat? That's the question. Nagpasa na ba kay
Opo,
lahat?
sir.
Okay, very good. So ito, I think, isa na yan, no? Similar lang sa problem kanina para ma-practice nyo. Dalawa, similar lang kanina. So I only gave you 2 sample problems or exercises. Thank you and God bless everyone.